there is a ghost in the machine that controls the future of artificial intelligence. It is not the neural network. It is not the billions of parameters, the terabytes of training data, or the thousands of GPUs humming in a data center. It is the invisible layer sitting right on top of the brain, the nervous system. The part that actually allows the genius in the server rack to pick up a tool, open a terminal, read a file, and write code. For the last 3 years, the American AI establishment believed they owned this layer permanently. They executed a brilliant, brutal strategy. They let the open source community have the brains. They let you download the weights, but they locked down the nervous system, building closed, proprietary wrappers and charging developers hundreds of dollars a month for the privilege of letting the AI actually do work. And then, quietly, in the middle of summer, a lab in Hangzhou released a framework that broke the monopoly. They called it DeepSeek Harness. It is not just a wrapper, it is a fundamental rewiring of how artificial intelligence interacts with the physical world of software. It debuted alongside their V4 models, and right now, in August, it has entered a highly guarded closed beta that is quietly rewriting the economics of the entire global developer economy. This is happening right now, today. If you want to understand how the most valuable layer of the AI stack just got open-sourced by the exact country the West tried to lock out, hit subscribe. It genuinely helps this channel bring you more deep dives like this one. Let's get into it. To understand why a harness is the most important word in AI this year, you have to understand the dirty secret of the artificial intelligence boom. The secret is this: large language models, on their own, are completely useless in the real world. Think about what an LLM actually is. It is a statistical text predictor. It is a brain trapped in a sensory deprivation tank. You can ask it to write a Python script to scrape a website, and it will output beautiful, perfect Python code. But it cannot run the code. It cannot see if the code threw an error. It cannot open a terminal, read the traceback, fix the bug, and try again. It is a genius that is completely paralyzed. To make the AI actually do work, you need an agentic loop. You need a piece of software that sits between the AI and the operating system. This software takes the AI's text output, parses it, executes the command in a real bash shell, captures the standard output, and feeds it back into the AI's context window, so it can think about its next move. This invisible layer is called the harness, and for the last 2 years, building a reliable harness has been the single most expensive, frustrating, and lucrative bottleneck in the entire software industry. Let me give you the real-world economics of this bottleneck. Because the underlying models were so hard to control, a massive industry of agentic wrappers sprang up in Silicon Valley. Companies built proprietary IDEs, autonomous coding agents, and enterprise orchestration platforms. They took the open-source brains, wrapped them in their own closed-source nervous systems, and charged you for it. The pricing was extortionate, and the market accepted it because there was no alternative. $20 a month for basic AI coding assistance, $200 a month for autonomous agents like Devin or Claude Code. Enterprise contracts running into the hundreds of thousands of dollars. The Western labs and their startup ecosystem had created what the industry quietly called the wrapper moat. The logic was ironclad. The base model is a commodity. It will eventually be free, but the harness, the memory management, the tool routing, the error recovery, the IDE integration, that is proprietary. That is where the value is captured. That is where the toll booth is built. This felt like a problem with no real solution. The open source community had the brains, but they were stumbling around in the dark, trying to build their own nervous systems out of duct tape and third-party libraries. The West owned the agentic layer, and whoever owns the agentic layer owns the future of software engineering. So here is the question everyone in the open source community asked. If the agentic wrapper is where all the value is captured, why didn't the open source labs just build a better one? Why did it take until mid-2026 for a Chinese lab to solve the agent problem? The answer is that the Western open source ecosystem fundamentally misunderstood what the hard part of the problem was. They suffered from what the industry called the plumbing stigma. For years, building an agent harness was considered unglamorous. It was viewed as plumbing. The brilliant researchers at Meta, Mistral, and the top universities wanted to work on the sexy stuff. Scaling laws, attention mechanisms, mixture of experts routing, multimodal vision. Nobody with a PhD in machine learning wanted to spend their weekends writing JSON parsers, debugging bash execution loops, and managing context window truncation. So, the open source community outsourced the nervous system to third-party middleware. They relied on frameworks like LangChain or AutoGen, And this is where the physics of the problem broke down. Let me explain the specific, concrete weaknesses of the middleware approach. This is what makes the eventual fix feel earned, not magic. Weakness 1. The translation tax. When you use a middleware wrapper, the model is not natively trained to use the tools. The wrapper has to inject massive system prompts into the context window, begging the model to output its thoughts in a very specific JSON format. If the model hallucinates a comma or forgets a closing bracket, the entire agentic loop crashes. The wrapper spends half its compute just trying to force the model to speak the right language. Weakness 2. Context window pollution. Every time an agent executes a tool, the output of that tool gets dumped back into the context window. If the agent reads a massive log file or searches a codebase, the context window fills up with garbage. The model forgets its original goal. It gets confused by its own previous actions. The agentic loop degrades into an infinite loop of hallucinations. Weakness 3. The latency trap. An autonomous agent might need to make 50 tool calls to solve a single coding bug. If every tool call requires a full round trip to the API, parsing, execution, and return, the latency compounds. A task that should take a human 5 minutes takes the agent 45 minutes and costs $3 in API tokens. Because of these 3 physical realities, the dismissive nickname for open source agents was brittle toys. They were great for Twitter demos. They were useless in production. The Western incumbents looked at this mess and smiled. They believed that open source would never build a reliable production-grade harness. The wrapper moat was secure. That assumption held for 2 years, right up until DeepSeek decided that the plumbing was not a side project. It was the main event. Here is the twist. And this is the part that changes everything about how we build software. DeepSeek did not try to build a better wrapper. They did not write a better LangChain. They looked at the equation and realized the industry had it backward. The West treated the agent as a product you buy. DeepSeek treated the agent as a mathematical formula. Agent equal model plus harness. And they realized that if you want the agent to be perfect, the harness cannot be a piece of duct tape stuck on top of the model. The harness must be baked into the model's actual neural weights. Let me walk you through the mechanism, step by physical step, of how DeepSeek Harness actually works and why it destroys the Western wrapper monopoly. Step 1. Native tool use routing via MIOE. Remember how DeepSeek v4 uses a mixture of experts architecture. They did not just use it for storing knowledge. They used it for tool execution. When the model decides it needs to read a file or run a bash command, it does not output raw text and hope a wrapper parses it. It routes the token generation through a specific tool use expert network. This expert is natively fine-tuned to output perfect, mathematically guaranteed executable syntax. The translation tax drops to 0. The model speaks tool natively. Step 2. Separable architecture. This is the strategic masterstroke. DeepSeek made the harness completely separable from the model. The formula is agent equal model plus harness. This means you are not locked in. You can run the DeepSeek harness using a Western model, or you can run the DeepSeek v4 model inside a Western IDE. By making it separable, they turned the harness into a universal standard, an open protocol, rather than a walled garden. They are not trying to trap you in their ecosystem. They are trying to become the TCP/IP of AI agents. Step 3. Speculative decoding integration. This is the deep physics that nobody in the West is talking about. DeepSeek v4 Flash comes with a speculative decoding module attached, known as DSpark. In a normal agentic loop, the model generates a tool call, stops, waits for the environment to execute, and then generates the next thought. DeepSeek Harness uses speculative decoding to predict the outcome of the tool call before it even finishes executing. It drafts the next 10 steps in latent space, verifies them against the tool output in milliseconds, and accepts the draft if it matches. This collapses the latency of a 50-step agentic loop from 45 minutes down to a fraction of the time. It makes autonomous agents feel instant. Step 4. Sub-agent delegation. The harness does not just run one brain. It lets you pick from 4 main coding brains and orchestrate up to 9 sub-agents. You can assign the v4 Pro model to handle the high-level architectural reasoning, while delegating the tedious low-level file reading and syntax checking to the v4 Flash model. The harness manages the state, passes the context between the sub-agents, and ensures the memory does not degrade. And here is the brilliant part. The old weaknesses of open-source agents, the JSON hallucinations, the context pollution, The latency trap. They do not get fixed by writing better wrapper code. They disappear because the substrate changed. The model was trained from day one to live inside the harness. That is not a metaphor. That is just the math. When the brain and the nervous system are grown together, the organism actually works. But architectural diagrams and GitHub repositories are one thing. Real-world deployment is another. And this is where the story shifts from a clever open-source project to a geopolitical earthquake. DeepSeek Harness made its public debut on July 31st, alongside the V4 Flash model. But the real move happened in August. DeepSeek opened the doors to a highly guarded closed beta testing phase, and the way they are managing this beta is a masterclass in community engineering. To get access to the DeepSeek Harness beta, applicants are required to submit open-source projects. They are not just letting enterprise customers in to kick the tires. They are actively recruiting the best open-source developers on the planet, forcing them to integrate the harness into public repositories, and using them as a massive distributed QA team. Every developer who gets access is simultaneously testing the framework and building the public ecosystem for it. And the benchmark numbers that are leaking out of this closed beta are terrifying the incumbents. On DSBench-Hard, the industry standard for testing autonomous coding agents on complex multi-file logic tasks, the official DeepSeek V4 Flash, tested using the DeepSeek Harness, scored a 59 on 6. Let me ground that number for you. A score of 59.6 on DSBench-Hard means the agent is successfully navigating complex code bases, identifying bugs, writing patches, and executing tests with a success rate that rivals the absolute bleeding edge of CLO. Said source, $200 a month Western agents. And it is doing it using a model that costs literal pennies per million tokens. But the harness is just the foundation. DeepSeek is actively building DeepSeek code on top of it. This is a dedicated, fully integrated AI coding agent, comparable to Claude Code or Cursor, but built entirely on their own open stack. Now zoom out to the economic scale of this. The Western developer tool ecosystem is a multi-billion-dollar industry. Companies are valued at billions of dollars based on the assumption that they own the agentic wrapper. DeepSeek just open-sourced the wrapper. They released a framework that lets language models operate as autonomous agents, and they gave it away. Every month, the adoption compounds. Developers are realizing that they do not need to pay a SaaS tax to a San Francisco startup when the underlying harness is free, open, and natively optimized for the most efficient MIUI models on Earth. The switching cost is dropping to zero. The wrapper mode is evaporating. This is happening right now, today. The closed beta is turning into a public standard, and the companies that built their valuations on proprietary plumbing are suddenly looking at a future where the plumbing is free. But here is the honest part of this story. And I want to be straight with you, because this format does not do blind hype. DeepSeek Harness is a monumental achievement in agent orchestration, but it is not a magic wand that instantly makes autonomous AI flawless, and pretending otherwise ignores the brutal physics of agentic loops. First, there is the reality of context window degradation. Even with native tool use routing and sub-agent delegation, long-running autonomous tasks generate massive amounts of intermediate state. If an agent is tasked with refactoring a legacy codebase that spans thousands of files, the sheer volume of tool outputs, file reads, grep searches, compiler errors, will eventually push the limits of even a 1 million token context window. The harness manages this better than any wrapper in existence, but it cannot magically create infinite memory. For truly massive, multi-day engineering tasks, human intervention is still required to summarize and reset the agent's state. Second, there is the harness tax on compute. Running an autonomous agent is fundamentally different from running a chatbot. A single user request might trigger 50 separate API calls to the model as it reasons, executes, checks errors, and reasons again. Even if DeepSeek's V4 Flash is incredibly cheap per token, the sheer volume of tokens required to sustain a complex agentic loop means the absolute cost per task is still higher than a simple prompt response. The harness makes it economically viable, but it is not free compute. Third, the IDE integration friction. DeepSeek Harness is a back-end framework. It is the engine and the transmission, but developers do not interact with frameworks. They interact with integrated development environments, while the harness is separable and can theoretically be plugged into any interface. Building the polished, buttery smooth UI/UX that developers expect from tools like Cursor or GitHub Copilot requires a massive front-end engineering effort. DeepSeek has the back-end locked down, but the front-end user experience is still a battlefield. None of this erases what the engineering has already proven. It simply marks the distance between a revolutionary open-source framework and a polished, consumer-ready monopoly. The physics of the agent loop are solved. The rest is UI, memory management, and time, which brings us back to the bigger picture this whole story has been building toward. Because this is not really about a coding tool, it is about the completion of the full stack. For the last 5 years, the global AI race has been fought in layers. The West tried to lock down the silicon layer by banning EUV lithography. China responded by building multi-patterning DUV and optimizing for Huawei Ascend chips. The West tried to lock down the model layer by keeping the frontier weights closed and expensive. China responded by open-sourcing DeepSeek V3 and V4, breaking the pricing cartel. And when the silicon and the models were secured, the West retreated to the final redoubt, the agentic harness, the proprietary wrappers, the closed-source IDEs. The belief that even if China could build the brain, the West would forever own the hands that do the work. That redoubt just fell. With DeepSeek Harness, the full stack is now complete. Domestic silicon, domestic base models, domestic agentic orchestration, a completely sovereign, open-source pipeline, from the physical transistor all the way up to the autonomous code-writing agent. The world that ran on San Francisco developer tools didn't announce its own ending. It just started losing ground to a formula. Agent equal model plus harness that was written in Hangzhou, open source to the world, and optimized to run on hardware the West tried to ban. So here is the question I want to leave you with, and I genuinely want your answer in the comments. When the tools that write the world's software are no longer controlled by a handful of venture-backed startups in California, but are instead an open, decentralized protocol maintained by a global community and powered by Chinese architecture. Who actually owns the future of the internet? The people who wrote the original code, or the people who just open-sourced the machines that rewrite it? Drop your answer below. I read every single one. And if you want a front-row seat for the next time an entire industry's moat gets evaporated by a single GitHub repository, hit subscribe. The next few years of this story are going to move faster than anyone expects, and you are going to want to be here for it. I will see you in the next one.